Hello everyone. We are learning about force and the laws of motion. Up till now, we have seen the first two laws of motion. These two laws of motion were with respect to inertia and momentum, respectively. Today, we will discuss the third law of motion. This law is the most popular one because there are chances you might have already heard of it, but not in the context of physics. Visualizing football has been very important to understanding this chapter. So today, again, we will take the example of football. If two football players who want to kick the ball in their respective posts collide, what do you think will happen? They will both end up getting hurt. This is a classic example of the third law. Both were impacted because each applied a force to the other. So the player in green applied a force on the player in the blue and white jersey. Simultaneously, the player in the blue and white jersey exerted a force on the player in green. Since both of them were victims of each other's forces, they both ended up getting hurt. Let's take another example of this. Imagine you are walking. There is some kind of force applied since you can see motion. We know that force causes motion. What kind of force do you think this is? Is it a muscular force? Is it a force applied by the road? Firstly, think how you walk. One foot goes after the other, but you do so by pushing back the road. As you can see here, the feet of the person push the road backwards in order to move forwards. There is no visible difference in the road, but we can say that a force is being exerted. But why is a force even being exerted on the road? Because the road exerts an equal and opposite force on your feet to make you move forward. So, to overcome the force of the road and move forward, your feet also exert a force. Here we notice a very important aspect of these forces. These forces are equal and opposite in nature. This means that their magnitude is the same, but their direction is the opposite. We will understand this in a better manner soon. Here are two spring balances. These instruments are used in the laboratory to check the force of an object. Attach the end of one spring to the wall and the other to another spring balance. Pull the free end of the spring balance A. Check the reading of both of these balances. You will see that the balances show the same value. This proves that the force exerted by the wall as well as the hand pulling it is same in magnitude. Any of these forces can be called as action and the other as reaction. We cannot decide which force is action and which is reaction. When we apply a force on the road, we may think it is an action force, but it can also be a reaction force as a reaction to the force that is exerted by the road. Now let's see two very important properties of the action-reaction forces. The action-reaction always act on two different objects simultaneously. Let's take an example of this. This man is jumping off the boat onto the shore. As he jumps, he is exerting a force in the forward direction, but the boat moves backwards. So the force is being exerted on both of the objects, that is the man and the boat. We can also see that the forces are in the opposite direction as indicated by the arrows. The action and reaction forces have the same magnitude but different direction. These are commonly known as equal and opposite in nature. The magnitude is the same but the direction is opposite. This is the first property of the action-reaction pair. The next property is that the action and reaction forces may not produce accelerations of equal magnitudes. Recall this formula that we learned from the second law of motion. Force is equal to mass into acceleration. So the force exerted or applied is dependent on both the mass and acceleration. The force on two objects may be the same, but the acceleration and mass are different. Let's take the example of this bullet being fired from this gun. When a bullet is fired from the gun also recoils. The bullet goes in the forward direction with a high acceleration. The gun moves backwards. The force on both of these objects is exactly the same since they form an action-reaction pair. Let's see what their masses are like. The bullet is lighter, but the gun is heavier. Let's see their accelerations. The bullet is more accelerated while the gun is less accelerated. Let's understand this by using a little mathematics. If the action force and reaction force are equal to 10 Newton, then the mass and acceleration of the two objects must be in proportion. If we take the mass of the bullet to be 1 kg and the mass of the gun to be 5 kg, the resultant acceleration must bring the force to 10 Newton. Force is a product of mass and acceleration. We know the masses. So what can we say about the acceleration? To get the force as 10 Newton, the acceleration of the bullet must be 10 meter per second squared. 1 kg into 10 meter per second squared is equal to 10 Newton. What about the acceleration of the gun? For the force to be 10 Newton, the acceleration of the gun must be 2 meter per second squared. So this is how we understand that although the magnitude of the forces of the two objects may be the same, their accelerations can differ. The acceleration of the gun is much lower than the acceleration of the bullet since their masses also differ. As we know, Newton gave the three laws of motion. We have studied the first two, so let's come to the third law of motion. When one object exerts a force on another object, the second object instantaneously exerts a force back on the first. These two forces are always equal in magnitude but opposite in direction. We have studied each aspect of this sentence. When an object exerts a force on another object, it is called action. And when the other object instantaneously exerts a force back on the first object, it is called a reaction. An easier and much popular way to say the third law is, to every reaction, there is an equal and opposite reaction. You may have heard this in regular vocabulary, but it is now time to understand this in terms of physics. So this is the third law of motion as given by Newton. Remember all of the examples and it will be much easier to make sense of all of the laws of motion. Thank you, and I hope you've gained something from it.